let me close my data. Okay, so welcome to today's class. We'll be going through the visitor design pattern. Like I said, this design patterns, to be honest, it's a self-study thing. You have to actually go read the textbook and look at the examples, look at the code, look at because no matter how much I explain it, I don't know if it makes a difference, you guys will let me know. But I feel like I don't feel like I would make any difference. Maybe, I don't know. You let me know. So the talking about the visitor design pattern, right? So the visitor design pattern, in simple terms, it's when you want to when you have multiple objects, right? Let's say you have multiple instances. It's behavioral, right? It's a behavioral design pattern. Basically, you're looking at the behaviors. If you remember in OOP, right? I think I did talk about that. In OOP, the term behavior in terms of OOP, these are operations, right? Or functions. So we are looking at with the visitor design pattern, you're looking at the ability to add new behavior or new operations or new functions without affecting or making changes to the classes. So that's basically what a visitor design pattern is. But then it's still not full, it's not the full definition because you're looking at all those classes, right? There's still more. All those classes, they actually have unrelated interfaces. If all those classes have unrelated interfaces, unrelated in the sense that they're unrelated, like that's what there's no way to explain it any further. They're unrelated. They're not, or they're not. The interfaces they're not related to they're not talking about the same thing in a way. So if you have unrelated interfaces and you want to add new operations, functions, you want to add functions without changing any of the classes or the subclasses. Therefore, the visitor design pattern is more perfect in that scenario. So a visitor design pattern, right? What is its intent? What does it intend to do or intend to achieve? It intends to represent, yeah, it's a way of representing an operation to be performed on the elements of the object. So basically, you represent an operation or a function that's going to be used to perform operations on the objects. Because remember, how do we make changes to the variables or to the data of the class? Through methods, through public methods. That's how we make those changes. So it's a way with the visitor design pattern, it's a way for us to create an operation to represent an operation that needs to be performed. An operation is that it's like, in terms of operation, it's like, for example, I'm just thinking of examples. It's like, for example, let's say the doctor is going to perform an operation, right? The type of operation we can use a visitor design pattern for that, maybe, whereby we define what type of operation each doctor performs, right? For example, there's the heart surgeon, there's the one for the eyes, and the one for what are they called? Radiographers, right? The one for, I think, I'm not sure about what part. I don't know whether it's the bones or something. So you can represent an operation that needs to be performed on the objects. In this case, the object is you, the person, right? You are the person who's being physically operated on by the doctor. So that's basically what the design pattern is trying to implement or model. Because remember, this is design. We're trying to model something. It allows us to introduce a new behavior or operation without changing any of the classes of those elements. So we can introduce, basically, we can put in a new function without changing any of the classes, which is it should be, that's a very powerful way of achieving that, because that means, remember the Instagram and WhatsApp, all those updates that you get and you go to pick Google Play Store or Apple Store to make those changes or updates. It doesn't affect your usage of the app, right? You are still active on the app, even though it keeps showing pop-ups and saying, what is this WhatsApp or Instagram as the new version of this update. Click here to update. That means you're not affected in any way. Those changes that are added, they don't affect the existing classes of those elements. Because remember, okay, you guys don't know mobile development, but mobile development uses, to be honest, OOP is like the heart, it's like the oxygen of everything. Even graphics, like the reason why you're able to see an image right now is OOP. Because there's this thing called computer graphics, which chows, like I think it's like the medicine of of comsci computer graphics, because the math that's there. Hey, that math is a lot. Like it's hard. It's harder than linear algebra. It's harder than any math you've ever done before, because you also need to go study physics thoroughly, then apply physics in maths, and then once you've understood the maths part, then now only then can you now go to the code part, which should take you probably maybe 2 years to try and master that computer graphics maths, but it uses OOP a lot. So to be honest, OOP it's a very important thing. So even in mobile development, any feature you want to add, you actually create a class for it and create its accessors and getters and constructors, everything. Even a toString, you also create it, especially in Android development. If you guys join the FNB Academy thingy, you will realize that they use Java to learn to create mobile apps. To be honest, Java is quite strong in the Android space. A lot of things, or a lot of apps are implemented using Java. It's only till recently when they started implementing using different tech stacks. We call them tech stacks, right? Or different programming languages. So that's basically what the visitor design pattern is trying to achieve. So come on. We'll go to the next and see. So this is the example, right? Remember what I talked about, that we are defining an operation that should be performed on an object. So for example, you have here 3 objects, right? Or 3 classes. This will be the classes, right? And then this is the object that is performing it on. So a rectangle draws on that object, right? We can call a draw method to draw a rectangle on this object. We can call a draw method from the second class to draw that object. Same applies to the triangle. So operations that should be inside the class are placed in another class. So visitor design pattern, right? So basically, instead of remember these draw methods, right? They need to be placed inside of each of the classes, because it draws each of those instances, right? Or each of those classes. Basically, we have a draw inside rectangle because we want to be able to draw a rectangle. We have a draw inside a circle because we want to be able to draw a circle, and so forth. So instead of having those draw methods, you can actually put the operations, because if you look at the draw method, right, it most probably gonna have a draw method itself and what we call utility methods. These utility methods are basically helper methods that help you do the drawing. So what the visitor design pattern tries to achieve is that instead of creating all those, because they are common, why are we, remember, programmers are lazy. Why should we repeat ourselves every time we add a new shape? Because remember, these are all shapes, right? I'm gonna traumatize you a bit. I don't know if you did it, but there's something called UJ shape. I think they are UJ shape, ComSci 1B, if you still remember. Yeah. When days were dark. So we have all those functions, right? And they also have their own utility methods, basically helper methods that help draw those shapes. So why should we repeat ourselves every time we add a new shape? So let's say, for example, we add a rhombus. That means inside the rhombus class, we have to copy and paste all of those functions again inside of the other classes, even the utility methods that help us to do the drawing. So this is the design pattern. What it does, instead of doing all of that, you create a separate class, right? I want you to pay attention to what I'm explaining right now. You create a separate class that has the draw method and all of the utility methods that help you to do the drawing, or that help to facilitate the drawing. All those classes, all those functions, right? You put them inside that separate class. Then, since they're now inside a separate class, they can do what we call visit the objects themselves, right? So basically, they can visit a rectangle to do the drawing. They visit a circle to do that class visits a circle. It visits a rectangle. It visits a triangle. to do the drawing. In a way, right, technically, it's like abstract method. I think there should be an abstract method when you look at the diagram. I think there should be abstract method somewhere. Because remember, an abstract method, you can put it, you can basically, it's like you define a template, a function that's going to be common, or even utility methods that are common, and then you extend that class. Because remember, we talked about design patterns that they use a lot of inheritance. So technically, it's similar to that. And then you extend, and then you override, right? By extending, you're gonna have to override that draw method and write your own implementation. So we actually still, technically, the thing is, smart people, they try to act, they try to act more smart than they actually are. Because the visitor design pattern is actually talking about an abstract base class, but it's like you're putting fancy English behind it. That's basically how I've seen it. I'm seeing it now. So, for example, draw method, it can be implemented differently by each subclass. You see, do you see polymorphism also here? There's polymorphism. Remember polymorphism, whereby one function can have multiple different implementation, whereby the word poly means many, form. So polymorphism, morphism, right, means form. So poly means many. So many forms, polymorphism. So it's going to be basically, if you call the same method, but it does something different. So for example, if you call a draw method, then you pass in a rectangle, it draws a rectangle. But if you call a draw method and you pass in a circle, it draws a circle. But the function prototype or the function syntax is exactly the same throughout all the instances. I hope I'm making sense. By each subclass, but it probably uses the same utility. Yeah, we're talking about the utility methods that are repeated. We don't want to repeat them again. For example, let's say for some weird reason you're finding a maximum or and a minimum. Just a simple example, because I don't know what to think of right now, because these are different shapes, they have different properties and rules. Some have length and breadth, length and width, some have radius, some have length, width, width, and height. So they have different, they're all these shapes are different in their own way. So let's say you're finding a maximum and a minimum in each of the class. That means every time you create a new shape, you copy and paste that same calculation. Basically, you recalculate the max, you recalculate the min. So do you see how much work that's going to be? Because that means that every time you introduce something new, you're going to have to copy and paste and repeat yourself. We don't want that. So visitor design pattern avoids that. So there's the thing that we're trying to achieve, which is we create a separate class that has this draw method, of which this draw method, it visits the things that it needs to draw. So it visits a rectangle, it visits a circle, it visits a triangle, and then they do the drawing to draw this object. Obviously, if you if you draw visits the rectangle, that means the object that's going to be drawn is a rectangle. And then if the draw method visits the circle, that means the thing that's going to be drawn is a circle. So instead, you create a visitor class containing all these methods related to drawing, and you have it visit each of the subclasses. So that class that you're going to create that has all those common methods, which is the draw method and its utility methods or helper methods, we're going to call that the visitor class, because why is it visitor? For example, think of it, I want you to always liken or equate something that you see in school to the real world. When you have a visitor, right? Like that person is the one who's visiting you. So we call a person who comes to you to see you, we call that a visitor, right? Of which that's what this is doing. It's going there. It's going to those shapes, of which you can view as houses. So if this person is going there to this rectangle house, if we call that him the visitor. And then this person who's receiving that person, that visitor, we call that I don't know what to call it, but it's the person who's being visited. That's what I'm gonna call it. I don't want to do spiritual things and say maybe it's a visitee. Maybe it's a thing, I don't know. But it's just the person who's being visited. So the diagram ends up looking like this. Yeah, so it ends up looking like that. And then what does visiting mean? I agree with talking about that. This guy over here is a visitor. He visits each of these instances, right? So what does visiting actually mean? So visiting is basically when an outside class wants to, not can, that's incorrect. When the outside class wants to have access to another different class. Remember, like I said, we're going to create a separate class that we're going to call the visitor class, which is going to help us do the visiting, right? Basically going to those instances or to those classes to visit. So obviously that's a different class. That means it doesn't have, remember, there's things like there's access modifiers like private, protected, and public, right? Remember, when you create variables inside the class, we all make them private, meaning if you are not this class itself, you don't have access to them. But we can create what we call accessors and getters. No, same thing. What am I saying? Accessors and mutators, right? We can create accessors and mutators and restrict and limit and describe which things should only be accessed and which things should only be changed, or which variables should be, whereby you should do both accessing and mutating. Then we call those functions in order to make changes to those variables inside that class. So that's basically what it's explaining there. That if you want to have, if an outside class wants to have access to another class, you'd have to call the methods, the public methods. And then in the visitors case, basically, since we're talking about accessing public methods, when you look at that process of accessing public methods of a class with respect to visitor design pattern, it's basically visiting each class means calling the public method that's already set up it's already, you basically call a method that's public inside, that's already set up that is already set up for this, right? Which is basically called accept. So in other words, it's kind of vague the way I put it there, but what it means is that you have this visitor, and then these are the people that are being visited, right? They can choose whether to accept that visit or not. So therefore, they're going to have accept methods. So that's basically what it's saying there, that you're going to, in terms of visitor, you're going to visit through a public method by calling a public method to visit. And then the person who you want to visit can either accept the visit or not, or they need to actually accept the visit in order for it to be facilitated. So that's why you're going to have a method called accept. So that means you're going to have a method called visit to help us visit. And then we pass in the visitor, the person who's going to do the visiting. And then that visitor, we're gonna visit someone, right? And then the person who's being visited is gonna have an accept method, whether you can choose to accept it or not. Which means that if you think about it, right, remember these are the subclasses, which means each of the subclasses should have an accept method. If I'm not mistaken, they should have an accept method, all of them. The accept method has one argument, which is the instance of the visit. As I've stated, the accept method, right? It needs to accept a visitor because that's the person who's doing the visiting. So therefore, it takes in an instance or something of type visitor. I hope that makes sense. And in return, it calls the visit method. So the accept method, it takes in a visitor, and then after we've accepted that visitor, that means that visitor is allowed to visit, right? If you think about it, right? Let me go back to that function. It's called accept, takes in a visitor, right? That we're going to accept to visit us. Once you've accepted that visitor, that same visitor, you see that visitor, he can now visit. Who can he visit? Us, which is me. He can visit me, myself. He can visit me. So that's why he passed this there. So I think it should be a bit clearer now. And it calls the visit method of the visitor, passing itself as an argument. Basically, you need to pass the person who's being visited, which is you. So you pass this. That's the person who's being visited. In layman's terms, it means that every instance you want to visit is passed inside the visit function. So that means the thing you want to visit here, right here. Actually, that's this. It's the subclass itself that you want to visit. So yeah, I hope that kind of makes sense. So in terms of diagrams, you can view it in this way. you have a visitor who's going to do the visiting, right? Yeah, who's going to do the visiting, and then this is the visited person, right? So the visitor does the visit. Okay, the visited instance, I don't know why they did this diagram like this, because it's kind of confusing. I think it actually makes sense. It makes way better sense when I was explaining it here. So this is basically a visitor who's visiting someone, and then obviously this visited person needs to accept, right, this visit. And then, yeah, and then I also put it here as an example, the code. So every object you want to visit must have the following method. It needs to accept the visit because that's the person who's being visited. If you check, that's why I was saying each of these shapes need to have an accept method because it needs to accept that visit. Basically, you need to be welcomed in order to visit, right? Which is in real world, right? Which is also true. It's actually like that. If you're not welcomed, you shouldn't visit. So you need to be welcomed. Basically, you need to accept your visit. So accept that visitor. Once that visitor is accepted, he can now visit us. So he can now visit us, right? So that means V, which is that visitor, dot visit. He visits who? Us, which is me. So that's why I'm gonna pass this thing. And then when should you use this pattern? So you should consider using a visitor pattern when you want to perform an operation on the data contained in a number of objects that have different interfaces. Like I said, it's you have multiple objects, right? That have different interfaces. If they have, that's the number one thing you should look at. If they have different interfaces that they're realizing, right? Remember, you realize an interface. If you have each of these objects has different interfaces, basically they're unrelated. Then and and each of these interfaces they have an operation that needs to be performed on the data, and it's unrelated. Therefore, you can use a visitor design pattern. Visitors are also valuable if you have to perform a number of unrelated operation. As long as it's something that's unrelated and you're doing you're performing an operation on the data, and these operations are unrelated, you'd know for a fact that that's a visitor design pattern that you can use. Visitors are a good choice when you do not expect many new classes to be added to your program. So if in the question paper it says that not many, basically they tell you that you're not going to add a lot of new classes. That's also another hint on when to use this pattern. But remember, you need to combine all of this, how do I put it? All of this, it's basically a checklist. You need to make sure all these conditions are met. For example, you have objects that have different interfaces. Basically, the interfaces are unrelated. Therefore, if they're unrelated, that means they perform unrelated operations on these classes. If they perform unrelated operations on these classes, and those classes that the new classes, when you look at the maintenance, when you want to add new classes, those new classes won't be a lot. As you can see, it's only good when you do not expect many new classes to be added. So you'd have to look at all those things in conjunction, right? Make sure all of them they're working hand in hand together, right? Then we have applicability, which is in a way to kind of explains when is this applicable? When is design pattern applicable? Technically, kind of means when to use it technically. So an object structure contains many. So when you have an object structure that contains many classes of objects with differing, right, interfaces, they differ, differing interfaces, which is basically what I've said previously here. It's just that in the textbook, because I was alternating between two textbooks. So the one textbook, which is the Gang of Four textbook, is the one that is this, right? I think it also had this. Yeah, it also had this. I had to put it in my own words, but it also talked about that. So they kind of repeating themselves in that textbook. And you want to perform operations on these objects that depend on their concrete classes. So basically, another hint is that there's you have these classes that of objects that want to perform different, they want to perform unrelated operations, and of which these operations that they want to perform, they depend on their concrete classes. So like I said, there has to be some abstract class. There has to be something abstract because we're going to have abstract and some concrete things. Not to be mistaken with the, I think, factory. It also has, yeah, they have an abstract factory and I think a concrete factory, something like that. But we'll see when we get to that design pattern. Many distinct and unrelated operations need to be performed on objects in an object structure, and you want to avoid polluting their classes with these operations. So if you want to avoid polluting their classes with these operations, this visitor design pattern is perfect for you. So the visitor lets you keep related operations together by defining them inside one class. When the object structure is shared by many applications, use visitor to put operations in those applications that need them. So when the object structure is shared by many applications, basically it's gonna be used quite a lot. That's another reason to use a visitor design pattern. And then these classes of the defining the object structure really change, but you often want to define new operations over the structure. It points back to adding new features, new functions. Changing the object structure classes requires redefining the interface to all visitors, which is potentially costly because remember we talked about the costs and benefits. You need to also be aware of what are the costs and benefits of each design pattern because they might also ask you to compare. Remember, the comparison is something that's very plausible, right? Something that they can do. They can ask you to compare, like compare proxy and visitor. What are the costs and benefits of each? When to use each? All those things. They can ask you all those things. I don't know how they expect you to know because they didn't put it in the slides, and it's not in the textbook. So they kind of help you, expecting you to be an adult, a grown person to go do your research without telling you to go do your research. So basically, it says things related. It's related to unrelated. Or what is unrelated? Okay, if I use this word, in this design pattern, let me not use the word related because I can use related and unrelated in one sentence. Kind of makes no sense. But this design pattern is mainly focused on on unrelated operations. If you have things that are unrelated that you're trying to relate to each other, what you can do is you create a separate class, and then that class only stores the things that are related, right? So as there's the structure of how it would look. So let me see if I can zoom in here. Right, so okay, this thing is cool. Uh, okay, it's not perfect. I thought it was. So as you can see, we have the visitor, which is going to be an abstract visitor, right? So we always have abstract and concrete. So we have abstract visitor, and then this is the person who's being visited. If you look at on your slides, right, it's actually kind of different. It's the same thing, but then they put it in different locations. So basically, they put it side by side. In this textbook for in the one that's written by the authors of design patterns, they did it this way. Which it's just exactly the same way as in your slides. It's exactly the same way. Just that here they kind of, I don't know, it's kind of plain. In your slides, they add a bit of color. That's it. So you have an abstract visitor, meaning you're gonna have a base class called abstract visitor, which is gonna have two concrete visitors. Basically, the complete classes that you're going to do, that you're going to the concrete are visitors, right? Then you're gonna have the element, which is basically the I think the element in this case here, you can view it as like the abstract base class of the classes that are going to be visited because you see they have an accept method because they need to accept the visit. So you go from this, right? This visitor, is going to be passed here via the accept method, of which we talked about it. There it is here. We pass in a visitor inside of our accept method because we need to accept that visit or that visit from that visitor. So after we have accept method here. So we pass in a visitor that we want to accept. Then we have concrete. So basically that means element in terms of shapes. You're gonna call it the abstract base class for my shape, which should be called shape. Then this would be the subclasses, rectangle, rhombus, any shape. Then they all, since it's an abstract class, this would be an abstract method. Then we override it to accept that visit in different ways. Then operation B and operation A, it's basically if those subclasses have their own unique operations that they perform, then you can also add them. It's allowed. They're just showing you that that's allowed. Don't think that all your classes should only have the accept method. No, they can have their own other operations. And then um, if you and then this is important over here. This is when we do the visiting. So we need to call the visit method. So there's the visit method, right? So we have concrete visitor, and then this lists the thing. You basically list the things that you're going to visit. Basically, you're going to pass in concrete element A, which is all the subclasses that you're going to visit. So you're going to visit a rectangle, visit a circle. So that's the visit method. Which basically, since remember inheritance. Hey, that's why I told you to read the textbook. Because this thing uses a lot of Java concepts like OOP. You need to understand deep what's going on. Remember that in Java, right, it's possible to do this. Let me show you. You can have public draw method, which takes in something of type shape, right? Remember, we talked about reference types. Remember, this is a reference type because it's the name of a class. So it's a reference type, meaning I can call objects or operations on this variable. So this function, right, is gonna do some drawing. So I don't know, whatever you're drawing, right? So let's say it's a draw method, right? Let's say we simply do, what is this? What is that thing? Delegation. Still remember in C++ when you did this. Yeah, I'm traumatizing you a bit. Yeah, it's similar to that. So but instead we just instead of using the arrow, just use the dot. So dot draw, right? We pass in thing we want to draw. Let's say each draw method maybe okay. Let's say it doesn't take in any parameter. Each shape. Now you can in Java, right? It's allowed for you to pass in when you call this function to pass in an instance of the base class or instances of the subclasses. Because why? If you remember in Java, you can also do this. Let's start here. You can say shape is equal to shape, and then say initialize it to a subclass. So you can say new rectangle. Right? This is allowed. Why? Because what's on the right hand side, right, is a something of what's on the left hand side. So on the right hand side, I have a rectangle. On the left hand side, I have a shape. So a rectangle is a shape. So that's allowed. Since that's allowed, that means even when I call this function, I can pass in any shape. So I can pass in, I can say this, I can say rectangle, rect, and then I'm gonna say, to call the draw method, I pass in an instance of rect. And I can also do the same thing for a circle. So circle, right? And then I pass in a circle. So that's allowed because a rectangle is a shape. Remember this function says it takes in a shape. So rectangle is a shape. Circle is a shape, right? So that means inside of my base class, inside of this visitor, concrete visitor, right? Basically, I would create, this is shape, right? This is shape, this is a shape class. This would actually be concrete shape. I think you can call it concrete shape. Then inside here, you're gonna have a visit method that takes in shape, right? Each of the shapes. Okay, this one in this here, I don't know why they would do that. They could have saved the time and used this concept that you can just simply pass in shape. Here, they want you to pass in one by one, as you can see. You need to have each method, which kind of makes sense because you need to have a visit method followed by the thing you're visiting, which is basically the subclasses. So you're gonna say visit, you're taking a rectangle because you want to visit a rectangle. And you say visit a circle because you want to visit a circle. Then visit a triangle. And then here you accept that visit, right? You're gonna have an accept method, which is gonna which you're gonna have all the concrete. Remember that these are the things you're visiting, the concrete elements or the subclasses that you're going to visit, which is rectangle, circle, and triangle. And then you use the visit method. You remember it takes in an instance of visitor, of which that visitor, right? That visitor, remember, it is a visit method, which takes in the things we want to visit. So since remember this accept method, right? If you remember this accept method over here, it's declared inside of the child classes or the subclasses. So therefore, if it's inside of, let's say for example, let me copy this. Let's say for example, this is inside the class for rectangle, right? This. So this is inside the class for rectangle. And then I'm going to zoom out a bit. Since this is inside the rectangle, it makes sense to use this keyword. Why this? Because this visitor is visiting this, which is me. So it's visiting this class, which is a rectangle. So that's why you do it this way. And to be honest, this accept method is the easiest method because it's going to be the same for all the child classes because you always pass this because it's inside of that. It's inside of that class that you are doing the visit. Is there someone speaking there? Oh yeah, you can. What's your question? Can you ask?
It's, I was saying that we don't see a screen.
I can't hear you.
We can't see a screen where you are implementing those things on the screen.
Are you asking about code?
Yeah.
Yeah, well, again, we're still explaining here. I will make an example. Again, we're still going through the theory part first, then we'll see it practically in code.
Oh, I thought you were coding that. I thought you were coding. So
No, I agree we have to start by understanding. We can't just go straight to code because if you go straight to code, you're gonna cram. And it's gonna
yes,
chop.
yes, I know. But where was saying these things, we we didn't see a screen. That's why.
Hey man, I don't wanna lie, I can't hear anything you're saying. Can you type it down, man? Can you just type? I can't hear you. I can't make out what you're trying to say. I'm hearing bits and pieces. Maybe that's why I'm unable to answer you. Just type it down there. So this is how it is. Yeah, it's not too bad, this design pattern compared to other ones. I think these design patterns are not too bad if you kind of sit down and you really think about it. That's when you realize, okay, it's not too bad. It's not that bad. Yeah, so that's and then we have things that we call consequences, right? So a visit makes adding new operations easy. Like I said, it doesn't have it doesn't affect the whole system. You only can add things easily because that's the whole goal of a design pattern. That's why I said you need to understand what the intent, which is the full scope, everything that that design pattern is trying to achieve. Because if you go by this approach of, oh, it just to be able, I need to be able to add new operations easy. Every design pattern does that. So that's why you need to look at all the other things that that design pattern looks at, right? So for example, there's unrelated operations. That's one of the key traits of to look at when you're trying to know whether to use a visitor design pattern or not. Visitors make it easy to add operations that depend on the components of complex objects. So those visitors, right, that are visiting, they make it easy to add new operations. You can define a new operation over an object structure simply by adding a new visitor. So you see that it doesn't affect the system itself. I can simply add a new visitor and then implement the code there, and then I've added a feature without affecting the whole system. In contrast, if you spread functionality over many classes, then you must change each class to define a new operation. Yeah. So that means you must change each class. Remember, if you don't do the visitor design pattern or this thing of making sure that it's easy to add new features or new operations, that means every time you add something new, you have to actually repeat yourself. And most of the time, if you are repeating yourself, there's some classes that will be affected. That means you have to go and visit each of those classes that are affected and make changes, which will actually cost you a lot because that means the system will stop, will be at a standstill. For example, imagine if Instagram tells you that I know for the next 10 hours we're updating, so no Instagram. Do you think people are gonna say, yeah, we accept that? No. People they want entertainment and they want it now. So you need to be able to sort of like divide, right? So write your code in such a way that when you add a feature or an update, it doesn't affect what's currently there. So that means users can still use their apps without having to be kicked out because there's some update that needs to be done. A visitor gathers related operations and separates unrelated ones. Yeah, that's basically what the visitor design pattern does. It takes the ones that are related and then it separates the ones that are unrelated. So basically, like I said, if you have anything that talks about unrelated operations, basically unrelated behavior or functions, this visitor is the one there. And they have unrelated like differing interfaces, right? The interfaces are different. That's also another key trait of a visitor design pattern. Unrelated behaviors, sets of behaviors are partitioned in their own visitor subclasses. Basically, it's just explaining the diagram. And then, yeah, everything else, uh, that's totally, yeah, there's quite a lot of, okay, I repeated the slide here. But yeah, you can, I feel like this one, you can go look at it on your own. Oh, because I'll send you the slides. Visitors approach assumes that the concrete interface is powerful enough to let visitors do their job. As a result, the pattern often forces you to provide public operations that access an element's internal state, which may compromise its encapsulation. Yeah, it may compromise its encapsulation, but not really, because we talked about, remember we talked about a class. If you want to make changes to a class and you are a different class, obviously you can't have access to variables. You would have to do what? You'd have to create accessors and mutators, right? We talked about that. Then you call those methods to make those changes to those variables inside of that class. So that we call that encapsulation because it's encapsulated in such a way that okay, there's abstraction and they kind of work together, but we say that that's encapsulated because you can view it in terms of a capsule, right? Like a pill. So if you look at pills, most of the time I get it. One side is smaller, the other side is a bit bigger, or if it's the same size, but then there's something in between that's like a line that divides left and right. Then think of it as on the left-hand side, that's where you have your variables, and then on the right-hand side of that pill, you have your functions. Hence, they say encapsulation because they liken that to a capsule. So here it says that it can break encapsulation because of the visitor's approach and things like that. So I think that should next. I think tomorrow we should now make an example of a visitor design pattern, basically implemented writing a full class. Basically, we implement all of these classes from scratch, and we make an example from that, and then we write the code, and then we try. Once you're done with the system, right, we're gonna start with two subclasses. Let's say maybe we're doing shapes. It's up to you, whatever shape we're doing. We do shapes or whatever, or fruits. Then that example that we have, we try to add an extra fruit or an extra what is this? An extra shape. And then we see if that doesn't affect the full system because we need to see it with our own eyes in code. We see what they're talking about, that, oh, there's someone who's visiting a visitor, and then there's someone who's to accept that visit. And then if that visit has been accepted, then we call the visit method to do the visit. Because once it's been pre-approved or approved to visit, then we can do the visit. So we also need to have a visit method. We get all of that, but we want to see it in programmatically, meaning in terms of code. So that's basically what we call a visitor design pattern. You can also just now, I'll send the slides. You can also use the slides that they gave you at UJ, and you just refer to them, especially if you want to look at the diagram. But then I think now you have light. That's the main goal, is so that you can have some light. So that when you look at that design pattern, even when you look at the code on the slides, you'll be like, oh, I see what he was saying. Oh, visiting, visitor. We need abstract. And if you notice something here in the diagram, right? We always have abstract because remember, we need to achieve polymorphism. So since polymorphism is the same function but implemented differently, so there has to be some abstract classes. So we're always going to have an abstract visitor and an abstract if there's such a thing called the visitee. So an abstract visitee, the class is being visited. And then you're going to have a concrete visitor and a it doesn't matter how many concrete visitors you have. And then you're going to also have concrete visitees, or people that are being visited, the concrete ones. Remember, why did they use the word concrete? Because abstract, it means that it's incomplete. It's not concrete. For example, a building, when they're still making a building and they haven't put in all the windows and some floors are not there, the doors are not there, all those things, we say that's an abstract structure. It's abstract, meaning it's incomplete, meaning it's not concrete. And then when something is concrete, that means it's complete. And that, which is true, because if you look at abstract classes, right, whether it's an abstract visitee or an abstract visitor, they have an abstract method, basically a method without implementation. So that means that class is incomplete. It's abstract. So obviously we need some in Java, right? If you make a class abstract, it kind of tells Java that, listen, we will wait for someone within it's like it's a very bad example, but it's like generational cases, right? It's like I just decided to be like, you know what, this is not me, God, I'm not built that way, I'm not gonna break any generational cases. So that means my descendant, which is my kids, they have to complete that part, right? So it's sort of like that. So yeah, this is basically design patterns, visitor design pattern. I'm not sure if we're gonna cover other ones. So this thing is quite a lot in this thing, and then no matter how much I can explain it, if you don't go study it for yourself, then it's not gonna help. So I'll see how I'm gonna go about it. Maybe we do 2 more design patterns, but tomorrow we have to look at the code. We write it from scratch. Then once we see the code, then you can actually see it practically and see, oh, so this is how you visit, this is how you accept, and things like that. So yeah, that's it for today's session. We'll see you tomorrow when you look at the code for the visitor design pattern. So let me stop recording. So that guy, did he leave? He was supposed to ask the question. Or is a network problem?